Assalamualaikum warahmatullahi wabarakatuh and a very good evening. So today our group gonna do a presentation regarding the cooling tower. First, let me introduce my teammate. Fatih Noor Edrina, Muhammad Azrin, Muhammad Taufik, Muhammad Amir Haziq, Masa, Haikal Nazmin, and last but not least is Fakrul Asfar. So now let us look at the introduction part. So basically, what is meant by the cooling tower? The cooling tower is one of the most important devices in the chemical industry. For example, when the hot water comes from the heat exchanger, we use the cooling tower to cool it. The purpose of cooling tower is to cool relatively warm water by contacting with unsaturated air. The evaporation of water mainly provided cooling. So the cooling water are used to transfer heat from the cooling water to the atmosphere. It also promotes efficient water usage and prevent environmental damage. So where does the cooling tower are usually used? It is used in the power station, oil refineries, petrochemical plants, and natural gas plants. Cooling water is continuously circulated through heat exchanger to absorb heat from processed material and machinery. So basically, there are two types of the cooling tower, the cross flow and the counter flow. The main difference between the cross flow and the counter flow cooling tower are how the air moving through the cooling tower interact with the water cooling mechanism. In a cross flow, the air travels parallel in the direction of the falling water, while in the counter flow tower, the air travels across the direction of the falling water. So in addition, not all the cooling tower can be handled in the same way. The cross-flow cooling tower also has a wider area that allows one to quickly access each and every part of the cooling tower than the counter-flow tower that has a smaller area that makes it a little harder to reach part of the system. Laboratory cooling tower is a cooling tower unit from a commercial air conditioning system used to study the principle of the cooling tower operation. The laboratory cooling tower enables the speed of the fan to be adjusted for the cooling of the hot return water and the pump used to return the cool water to the water heater. Experiments can be conducted which study how the adjustment of one or both of these parameters affects the amount of heat removed from the water provided to the water heater. Now, let us look at the recommendation. There may be some flaws in the outcome of the experiment that can be improved. First, the equipment of the experiment should be inspected before starting the experiment to ensure that there is no leakage that could influence the results. Secondly, after 15 minutes of running the experiment, the temperature change must be recorded. The timer must also be synchronized with the running system to ensure the precision of the result of the experiment. It is also recommended to wear appropriate protective equipment and to follow the safety rule in the laboratory while performing the experiment in order to prevent any unwanted incident. Last but not least, students should perform the experiment at least 3 times to obtain the average result for each of the experiment. That's all from us. Thank you.
Alright, now I would like to talk about the theory and mechanism of the equipment for the cooling tower. So first thing first, that we must know about the theory of the cooling tower is cooling tower is a special type of heat exchanger that allows water and air to come in contact with each other to lower the temperature of hot water. During this process, small volumes of water evaporate, lowering lowering the temperature of the water that's being circulated through the cooling tower. In other words, a cooling tower cools down water to get overheated by industrial equipment and processes. as I explained before, the theory for the cooling tower is a heat rejection device that rejects waste heat to the atmosphere, which involved in the process in industry. It is done by cooling of a water stream to a lower temperature. We use water to extract waste heat from a system through the evaporation processes. We cool the working fluid near the dry bulk air temperature. Besides, we also need there is also three components of cooling systems, which consists of cooling tower, recirculating pump, and heat exchanger. Next, we move to the mechanism of the equipment. Number one is hot water from the chiller is sent to the top of the cooling tower, where it is released into the tower. Hot water from the chiller is sent to the top of the cooling tower, and is being released at the top. So the next is water is sprayed down to the basin through a heat exchanger. So basically water is supplied from here into the basin. Next is during the process, it is exposed to airflow that is forced, induced, or naturally drafted into the tower. The exposure to the ambient air converts the hot water into the vapor, while the remainder of water falls towards the basin at the bottom, where it is recycled to the chiller. So as I explained, this illustration will show the process. And finally, the vapor is pulled outside through fans at the top of the cooling tower. And water is added to replace what was lost during the process. So I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haikal Nazmin bin Mazrimi. I will present about daily application of cooling tower. The example of cooling tower, application of cooling tower is car cooling system. Car cooling system is very important to make sure the engine running in a optimal temperature. Car cooling system have radiator to increase surface area for higher heat transfer rate, fan to blow the cool air to the radiator, pump to pump the hot water to the radiator and make sure the water always circulate, water jacket covering the combustion chamber and absorb heat. The mechanism of the equipment. First, when we start our car, the water pump run and the cold water in the water jacket circulate from the water jacket to here at the bypass and go to the inlet of water pump. The water in the water jacket circulate to make sure the cold water absorb heat from combustion chamber. When water in water jacket getting hotter, the thermostat will open the flow and the hot water from water jacket flow to the radiator. In the radiator, the heat in the water was released by blowing the cold air toward the radiator by using fan, and the water in the radiator become cold and goes to water jacket to absorb back, to keep absorb heat from the combustion chamber. And for your information, the function of thermostat is to make sure the water in the water jacket getting hot before release to the radiator, because combustion of fuel need optimum temperature, which is not too cool and also not too hot, to make sure the engine gasket not leaking.
Assalamualaikum. My name is Fakro Asfar bin Ahmad Husni. For my part, I'm going to present about equipment and methodology. Okay, first, the equipment for the cooling tower consists of distillation and deionized water, salted cooling tower, control panel, and stopwatch for the experiment to be take the record. Okay, so this is an example of the cooling tower for the lab experiment that consists of orifice, water distributor, pack column, flow meter, receiving tank, air blower, diffusion pressure transmitter, makeup tank, control panel, and load tank. So I'm gonna go through this part at the methodology. Okay, for the methodology, the first part was the load tank. So the load tank need to be filled with ionized water. Okay, as you can see the number 1, the load tank at the top part of the cooling tower system lah. So the ionized water need to be filled inside here. Okay, then the makeup tank was replaced onto the load tank, and the nut was slightly tight. Okay, then so the makeup tank at number 8 is being filled here. Okay, they are replaced untuk load tank. Okay, then the tank was filled with the ionized water up to the 0 mark and the scale. After that, the appropriate tubing was connected to a different pressure sensor. So for the tubing, we have to make sure they are connected to a appropriate transmitter, so we can read the pressure when go through the experiment at the control panel. Okay, so after that, the desired temperature can be set up at the control panel before starting the desired experiment. Okay, then the heater switch can be turned on with desired power supply. The heater switch can be turned on at the control panel. Switch and pump. The pump can be turned on according to the flow rate that want to be set. The flow rate can also be read at the control panel. After that, after the damper was fully open, the fan can be switched on. Then next, the blower can be switched on after the water have passed through the cooling tower. Okay, so after the water have passed to the cooling tower, then we can turn on the air blower that is at number 6. Then let the system to be run for 20 minutes to ensure the fluid valve have been correctly adjusted. Then for the add-ons, we have to ensure the makeup tank will have enough sufficient the ionized water or if not, we can refill the makeup tank with more ionized water. Okay, for the shutdown procedure, first we need to turn off the heater switch located at the control panel and let the water circulate about 3 to 5 minutes until the water have been cooled. After that, we need to switch off the fan. Okay, at the control panel, located in the control panel. And lastly, switch off the pump and power supply. Okay. That's all for my part. Thank you.
Okay. Assalamualaikum. I am Muhammad Azrin. I'll be presenting about the application or the feasibility of cooling tower inside the industries. So there's several example I found. There is use of cooling tower industry. First is in plant industry or the chemical industry. And then above the building and also natural draft cooling towers. So first is the plant industries. The cooling tower is fabricated as the fiber reinforced polymer, which means it is this building is made by the polymer shape of fiberglass composite, which is stiffened with diagonal braces to withstand any weather condition. It is built a very strong structure, which means it can withstand any weather condition. So this cooling tower is used because the large volume of chemical warm chemical to be cool. For example, in this area, same concept as the cooling tower. It provide a fan and also the water inlet, and also there's a chemical warm chemical that or medium that should be cool. For the chemical, it cannot be exposed into the air, so there must be the piping, that there's small piping inside this building, so that the warm water is to be sprayed onto the piping of the chemical. So the next one is above the building. As we can see, this cooling tower can be used in schools or large office buildings or the hospitals, because this building produce enough heat by the chillers, or we can call air condition, which the air condition provide the cool environment inside this building, and the heat produced by chillers is sent to this cooling tower above the building or the located area, so that it can be cool again and to be sent again to the desired place. So the third one is natural draft cooling towers. It looks like this normal one, because these cooling towers is called as natural draft cooling tower because there is no blowers or fan above this cooling tower. It is around 100 to 200 meters of height. It can be cool. It is used to cool the hot medium without a constant water supply. So this cooling tower is quite for the operation cost is quite low. So the generated heat can be channeled directly into other process and drift to the upper part, which occurs by the different density between the warm water, which is evaporated water. So this type of cooling tower is for industrial facilities where the total heat is produced approximately 450 megawatt. So normally in production of electrical plant, so they produce lots of heat which is suitable for this type of cooling tower to be used.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin Adrina Begum Muhammad Shamsul. So I'll be presenting on the conclusion of this experiment. So in conclusion, the objective is to see the effect of the heater power onto the cooling temperature. The heater power used in this experiment is 0.5, 1 and 1.5 kilowatt, which result cooling range 8.4, 11.8 and 16.7 degrees Celsius, which also can be calculated as efficiency resulting of 105, 97.52 and 94.89% respectively to the heater power. These show that the higher the temperature of the water inlet, the higher the temperature change, and also lower the efficiency of the cooling water where the work bulb taken into account also. In that work bulb is the temperature of the air enter the cooling tower, where the lower the temperature of the work bulb air, the lower the temperature can be cooled by the evaporation of water. So the second experiment showed the effect on the blower opening into the cooling fluid, which is the blower is fully open, partially open, and fully closed, which resulting to 12.8 degrees Celsius, 12.7 degrees Celsius, and 21 degrees Celsius respectively. The efficiency of the cooling tower were also calculated to be 96.88, 95.26, and 42.38% respectively. So the opening of the blower making the air drawn outward, and it can be used to be cool the warm water. Hence, we conclude that the higher the heat load increment of the heater power, the lower the tower efficiency and also the necessity of the blower to cool the air in contact. Therefore, the objective of this experiment successfully achieved.